Math 2414, arc length video 4. Arc length example 3. Find the arc length of f of x equals the natural log of secant of x on the interval 0 to pi over 4. Guess we just jump right into it. We need the derivative and square added to 1 and square root that. The fact that this involves natural logs in trigonometry shouldn't intimidate you. Just jump in and do it. Let's start with the derivative. Well, the derivative of natural log is 1 over the inside. So we have 1 over secant. Then the chain rule says times the derivative of the inside. So we need to multiply times the derivative of secant, which is secant tangent. Well, the secants cancel. And so the derivative of that is just tangent. Well, that's not too bad. Let's go ahead and set up 1 plus the square of the derivative. Well, the derivative of tangent, the derivative is tangent, so its square is just tangent squared. But that's trig identity, it's Pythagorean identity. 1 plus tangent squared equals. If you didn't instantly say secant squared, you've got to know your trig identities better. Plus, with all the trig substitutions we did, that should be fairly fresh on your mind. Okay, so we're going to park that under a square root. Therefore, the arc length is the integral from 0 to pi over 4 of the square root of secant squared. Hey, the square and the square root cancel. Ooh, but if you're starting to have a migraine from everything I said on the previous video about canceling squares and square roots cancel if the thing getting squared is positive. So technically you have to make sure that secant x is positive. But the interval of values is from 0 to pi over 4. In other words, we're integrating, if you were thinking about unit circle, from 0 to pi over 4. This is in quadrant 1 where every single trig function is positive. So yeah, the square and the square root cancel. So we have the integral from 0 to pi over 4 of secant x dx. As I wrote in some of your previous tests, this is an integral that you just need to know. Some of you went through the motions of re-deriving how to calculate it, which, although admirable, is not really necessary at this point. You just need to know that the integral of secant is the natural log of the absolute value of secant x plus tangent x plus c if it were an indefinite integral. But this is an integral that you should have memorized. And this one's being evaluated from 0 to pi over 4. Now some of you will be quick to dismiss the 0 as the lower limit, because as I've mentioned in many videos, when the lower limit makes the derivative equal to 0, you can ignore it. But only if it's the lower limit and it makes the derivative, antiderivative equal to 0. It may not be immediately obvious, so you should really substitute it until you're convinced that it disappears. So let's substitute. Natural log absolute value of secant of pi over 4 plus tangent of pi over 4 minus natural log absolute value of secant of 0 plus tangent of 0. Now, I'm not about to go into a unit circle lesson about finding trig functions of pi over 4 and 0. You're in Calculus 2. You should be able to figure out those if you don't know them already. If you need some help, message me. You know how to get a hold of me. And on top of that, I don't think we need the absolute values anymore. These are in quadrant 1. All trig functions are positive there, so that's going to be nothing but positive. And we'll worry about this one in a second. Secant of pi over 4 is the square root of 2. Tangent of pi over 4 is 1. Not a whole lot to look at there. Minus secant of 0 is 1. Tangent of 0 is 0. We can't combine these, so they're just sitting there. We can combine 1 plus 0, but the natural log of 1 is 0. So our final answer is the natural log of the square root of 2 plus 1. This really wasn't that bad. I would argue that the worst part is remembering that the integral of secant is natural log of absolute value of secant plus tangent. But as I mentioned, that's something that you really need to just have memorized. That was a short problem.